SinBerBEST is an interdisciplinary group of researchers from UC Berkeley, NTU, and NUS, making a positive impact by engaging in research related to energy efficiency and sustainable technologies for building in tropics. In order to achieve our main objective, state-of-the-art cyber-physical testbed system is constructed, which could be accessed virtually via network, and its data could be analyzed anywhere else in the world. Located at the 11th floor of Create Tower, this facility will support research and the development of the following areas: innovative air conditioning, advanced lighting control system, indoor air quality, providing innovative sensing solutions, optimized demand response, and many others. The Mission Control Room is a centralized system to remotely monitor, control, and manage various subsystems like sensor network, building integrated microgrid, lighting control, air conditioning and mechanical ventilation, daylight emulators, and facade systems. All these 6 subsystems are divided in 4 rooms for safe, reliable, and energy-efficient operation. Integration of these 6 subsystems can be mapped individually using the central server software. Nanogrid is an experimental platform to support research activities on the next generation in building power distribution component and system in terms of efficiency, quality, safety, and resilience. It also offers an intelligent algorithm strategies for building power flow management in aspect of economic efficiency and environment respects. Operation system for building nanogrid is a standalone research topic. It needs to gather existing pieces of nanogrid facilities, data sources, utility grid, and user behavior into a cohesive, extendable, and programmable system. Nanogrid features include 1. Hierarchical control topology. Maintain the reliability and modularity inherent in a distributed structure system. 2. Based on open source, inexpensive to implement in a reliable fashion. 3. Web-based open system, ease of integrating new system and ease of writing new applications. 4. Scalable to suit different systems and applications. Air conditioning and mechanical ventilation, which is known as SCMV system. The objective of SCMV and ACMV control system is to implement real-time monitoring and control to achieve different temperature humidity target for each room and set desired CO2 concentration in the testbed. This will facilitate the study of various aspects of indoor air quality and thermal comfort in the 4-room testbed. Some of the major components in the ACMV systems are 2 air handling units, liquid desiccant dehumidification system, and the outdoor air emulator, of which the CO2 scrubber plays the major role to achieve the outdoor CO2 level. The block diagram of ACMV system will also indicate real-time signals beside corresponding components, as well as showcase power consumption estimate. These enable real-time monitoring to be in place to complement research needs. Daylight emulator is a wall panel made from an array of LED lights capable of emulating various scenes of outdoor light condition from sunrise till clear sky. This enabling us to do more daylight harnessing capability study, which is essentially important aspects for harvesting energy savings from artificial lightings. In addition, the daylight emulator shortens the duration required for outdoor lighting related experiments. Coupled with the developed advanced intelligent lighting management system, visual comfort is always being optimized. Geofencing feature is incorporated to enhance the light control capability based on the real-time localization. As such, the luminaries are only lit based on the user preference setting. In here, we also want to highlight one of key research for facade system, the translucent concrete panel, which is an ultra-lightweight cement composite embedded with array of fiber optics, transmitting light into the space while giving adequate structural support to the buildings. Indoor environmental quality, known as IEQ, is one essential aspect for building occupants. In these chambers, we study in detail the associated parameters and variables related to IEQ, which are primarily indoor air quality and thermal comfort. A multitude of sensors from wet temperature, dry temperature, a globe temperature, relative humidity, and CO2 are placed at various heights within the room to give us in-depth insight of air quality and user comfort. From there, all parameters for thermal comfort like predicted mean vote, and predicted percentage of dissatisfied could be derived. Geofencing is a localization technology that defines a virtual boundary. In doing so, a radius of interest is established that can trigger an action, such as activating electronic devices. Its benefits are showcased here with a lighting control system. When the geofence-enabled device, such as an iPad, enters the area of interest, the table lighting automatically turns on according to the user-defined setting. Vice versa, the lighting turns off when the geofence-enabled device leaves its boundary. Building in a Briefcase, or BIB, is a portable sensor network platform that is easy to deploy in any building environment. It is capable of collecting a rich set of environmental parameters such as lux, temperature, relative humidity, and positioning data. Once the sensors are distributed, the environmental data is collected and communicated to BIB router via TCP/IP protocol and Wi-Fi technologies, which then forwards the data to the central database in a secured manner. With 100 square meters footprint, SinBerBEST testbed is highly configurable to suit different needs of building experiments. 2 chambers at north are dedicated for lighting and facade experimentation, and the partition could be joined and separated easily by movable partition wall. As such, twin chambers experiment could be carried out seamlessly. Air duct and chilled water supply could be found under the raised floor and also at the ceiling space, which offer various methods of air conditioning and distribution to be tested, like displacement ventilation, radiant cooling, active chill beams, and many others. A smoke machine is also placed for a quick study of airflow from various air diffuser units located within the room. To support research activities within the testbed, this lab is equipped with tooling room for a quick prototyping and modification of fixtures for research use. Here are the layers of equipment sitting inside the tooling room: circular cutting machine, grinding machine, drilling machine, filing machine, and fume extractor. The compact artificial sky heliodon is state-of-the-art, simulating the sky patch and the sun path projections over small-scale building model for in-depth daylight fenestration study and shadow casting study. Unlike the preceding approach, the scale model itself could be rotated freely via kiwi-shaped turntable to better reflect the actual latitude and the incoming light angle. Henceforth, we are able to replicate every kind of sky condition statistically or mathematically. In addition to the machines in the tooling room, 3D printer is also added for creating small fixture prototype made from PLA plastics. The lab is also complemented with various kinds of personal protective equipment like face visor, gloves, and etc. to enhance safety operations. As it is, safety is of paramount importance and management places high emphasis on good safety practices at all times. There are 2 weather stations placed at Create, one at the rooftop and one at the ground floor. These weather stations are served as a reference for simulation and building performance analysis. With all supporting facilities, from daylight emulators, highly configurable facade wall, network of air duct and chilled water supply at both ceiling and under the raised floor, robust and innovative sensing system, fully controllable nanogrid system, highly intelligent lighting monitoring system, centralized and accessible experiment data worldwide via OSI Pi database system, SinBerBEST testbed is in a favorable position to carry out research work related to energy efficiency and sustainability in a tropical building. It also will be able to support research, development, and testing in the following areas: innovative air conditioning method and deployment, distributed part-time, parts-based VAC and lighting control, innovative toward air quality, thermal comfort, and visual comfort, innovative sensing system, next-generation lighting system, daylight harnessing system, demand response, configurable grid interface while integrating renewable storage, and also different passive facade system.